first, we need to install this utility. So to install that, we can either download the zip file and then extract in a folder, or we can clone if we have Git. I'm going to go with the second option, that is using Git to clone this repository. So go to a folder where you can download and install it, and then from it, clone it using the Git command line utility. And once it's cloned, you can see you will have the repository locally, and then go inside the repository and where you can see the files. So now to install this, it is recommended to create a new Anaconda environment. So all of the dependencies are installed inside the environment. That is particularly important for this package because it relies on an older version of Python. So if you try to install this without creating an Anaconda environment, this might mess things up in your system. So I would highly recommend setting up Anaconda environment for this. So to create the environment, we can copy this code and then paste it. So that will create a new Anaconda environment as long as you have Anaconda installed. And if you note here, we are specifying the correct Python version here. So we can install all the dependencies, including the Pythia library. Okay. So now we have created the environment. Let's go ahead and activate the environment. And once we have activated, all we have to do is just type pip install dot. So now if we do that, it'll collect all the dependencies from the dependencies mentioned in the repository, and then it'll install all of them under the created Python environment. So if we take a look at the dependencies file, so these are the dependencies. So there are a bunch of them, and so some of these packages will only work in mainly this will work in an older version of Python, hence the requirement. Okay, so now that we have installed, to check whether it's been installed correctly, we can type AEVISPY -h, which should give us the help prompt. And it actually gives the correct help prompt. So now that we have this, let's go to the examples directory. And if we look up, here we have this test zip file, which is the same structure that I showed you earlier. So to use this, we can use this format. So the first is the command itself, AEVISPY, followed by the name of the structure. In this case, it's test.save, and the number of environment. For this structure, you have to give a guess about how many numbers of environment that you're looking. For this, I'm going to go with say 4, and then if you want to, make larger cell, larger supercell, you can do so by using the S flag. So you can specify, let's say you want to create 2 by 2 by 2 supercell. You can do so, but this is a pretty large structure, so I'm not going to do that. And likewise, if you are dealing with GST files, then you might want to specify the frame. So you can do so with this frame argument. And we have altogether 10 different descriptors. And if you want to plot only a few rather than all of them, you can do so using D flag. For example, if you want to plot only descriptors 8 and 9, say, for that you would do -D followed by 8 space 9. But I'm going to go with the default option, which is plotting everything. So with these two arguments, I'm just going to run it. So when it's run, it'll use the structure and then calculate the descriptor for the structure and then plot it. So now it seems it's done plotting. So let's go inside the folder and take a look at it. So now if I go inside the examples, I have this figure which actually has the different environments. Let me zoom in. This is a bit okay. So now So the structure is shown in three different orientations: X, Y, X, Z, and Y, Z. And in this orientations, we can actually see there's like one, maybe one or two type of environments here. This is not fully converged structure. Okay, so let's look at this. So one type of environment here and the mixed bag of environment on the other side, which we saw earlier. And if you look at this figure, you can also see that not all descriptors will come to the same conclusion, and that is the nature of the different descriptors. So this is something you had to play with. So take a visual look at the output, and then compare the different coloring made by different descriptors, and then see which fits more nicely with the expected results. So that is always had to be done manually. That's not been automated by this code. So, and yeah, so this is the utility, and I hope you find it useful in some aspect of your research. Thank you so much.